Okay, I think we're ready. It's 8 o'clock. Alright, so we're going to start our class on 3D printing. Let's go to this other screen. There we go. We're going to start this. We're going to meet about 30 times or so, something like that, over the summer. We'll do a variety of things. Most of the things that we'll do are going to be related to FDM printing, so that's fused deposition method or modeling, whichever M you want to use there, but it's the plastic kind of printing. So you melt plastic layer by layer, stack it up, and create some kind of object. We'll do some other types of printing along the way too. Resin printing, we'll do that a little bit, not as much. It's a little bit messier, but it does have its own advantages. But most of the time we'll be doing FDM printing. We'll talk about some other kinds like the metals and things like that. We're not going to be able to do metal printing here. That's a little bit more expensive process than what we'll be able to do right now. I got the little poll running over here. I don't know how many people have. Oh, six people have answered it. And it looks like everybody's at least done something with printing. So there's no no's on the poll, at least yet. Now there's 7. So either you have printed something yourself, so you've got one of these printers, or there's a couple, 3, that have had something printed for them, so you've seen the result of something printed. So this class, it does work a little better if you have access to a printer of your own, but if you don't, then you can get a lot of information from it. Not everything we'll do will have to be printed. Some of it is modeling, so we'll do some CAD modeling, we'll do some scanning, like how can you get geometry from the real world into your computer so that you can print it out later. And so you don't have to have a printer to complete the course. You can be totally on your own and without a printer and still get plenty out of the course and do fine. But if you do have one, then it opens up a lot more things. In fact, let me look at the syllabus here so that you can kind of see what we've got. So here is the Canvas syllabus. In this general tab right here, there's just some links. One of them is to a Discord channel that we have for the class. So I've been teaching this class quite a while. I don't remember exactly when we started, but a few years ago, actually during COVID, I guess, we started a Discord channel. And so there's several, I don't even know how many people, but several people in the Discord, and each summer and winter, a new group gets added, and so there are hundreds of people now that are in this Discord channel that if you get stuck on something, I look at the Discord, but there's also a lot of former students who look at it, who can help you out with something. There's a trade channel if you want to try and arrange a trade of some sort. Maybe you've got a whole bunch of one kind of filament and you want a little sample of another kind. There might be somebody that has that kind that you can trade with. If we were in person, we'd do that in class, but we're all over the place, so have to do a little bit more arranging to do that. Let's look at the syllabus here so you can kind of get an idea how the class works. I did call this class Additive Fabrication Methods, so you might hear the term additive manufacturing, AM. You might hear that a lot, and that is true. There is a term called additive manufacturing. We're not really focusing too much on the manufacturing. So whenever you put in manufacturing, you're thinking that there's going to be mass quantities of these parts that you're making produced, where we will probably make one of things, not set stuff up for mass manufacturing, but we will fabricate things additively. The additive word is kind of the converse of the subtractive. So traditional manufacturing processes that you might go to a machine shop and see are largely subtractive. So you take a block of steel and you cut away all the parts you don't want until you've got the bracket that you were trying to create or whatever. There are other types of manufacturing that might be forming. So you take a sheet of something and then you bend it into some kind of form. So maybe a vacuum forming process or even a sheet metal forming where you just bend it in certain angles. There are joining. So maybe you've got two pieces that you attach together somehow. So maybe you welded them, maybe you glued them, maybe you bolted them together, you know, with some kind of fasteners. But additive is different in that you start with a material, but you don't really form it. You don't really subtract away from it. You can do all of these things to it, but the whole idea is that layer by layer, you're creating just the shape that you want. Sometimes you supply some support materials, you know, something to hold the piece in place until it's finished printing. But in general, it's a different process from the traditional manufacturing processes. And we call it additive because you're adding material a bit at a time until you've got the part you want. All right, so this is just some of the things that we will go through. Not all. This is not an exhaustive list. This is just some of the stuff that we'll go through. We will hopefully successfully 3D print a standard benchmark part. In fact, that will be the benchy, the little benchy boat. That's what we'll use as our standard. It came into a copyright issue a couple of months ago, but I think we're okay to print that. If not, maybe we'll come up with a different benchmark. We've just been using that one for quite a while in this course. We'll write G-code. You know, the machine itself, well, I'm pointing to it, it's not on your screen right now, but the machine itself is a CNC machine. So it's a computer numerically controlled machine, and it runs on code, and the code is called G-code, and it is similar to a computer code, but it has its own little structure and own format. We'll generally not write our own G-code, but just so you understand how it works, we will write some of our little lines of G-code just in case you ever need to edit or do something very specific. Then you'll have ability to do that. In fact, today we'll do a little bit of this, some of the understanding of what's the main idea with FDM printing. We'll look at that today. We'll do a variety of filament types. Now, you don't have to. You can just use whatever filament you have. PLA is fine. Maybe you don't have a printer at all and you just do the optional assignments that don't need to be printed. But assuming that you want to print something, it doesn't really matter. We'll look at some of the assignments later so you can kind of get an idea. I will go through and show you a lot of different types of filament because there's an increasingly large number of filaments out there, and we will look at some of them. Probably not all of them because there are more and more all the time. But we'll see how they work. Some of them, most of them you can print on a regular printer like the one that I've got over here. Some of them take some specialized printers that you either have to do a lot of heavy modification or buy a more expensive printer or a different thing. But most of them you can print yourself, and we'll go through those. There is a almost guarantee that along the way, if you have your own printer, something's going to go wrong. It's not going to print right. The printer itself is going to break. We will look at troubleshooting most of the common stuff. We talked about filament types already. Slicing. So I said earlier when I was talking about the additive part that the process does a layer by layer deposition. So fuse, deposition, modeling. Fused meaning that the layers are fused together. They're attached to one another. And the deposition mean that they're deposited in a certain pattern. Well, in order to create that pattern, you have to slice the geometry. So you've got some kind of 3D geometry that you've either modeled or downloaded, or maybe you scanned it in from the real world. All that geometry has to be sliced into individual layers that the printer, the slicer can turn into G-code, that the printer can read the G-code and then move around in such a pattern that it creates the object you're trying to create. So we'll talk through most of those major settings. These are just things that I meant. If you do have a printer, so the one that was sitting beside me here is a Ender 3. You don't have to, it's probably not even the best printer to get anymore at the price point. You can still get them cheaper than most, So if you're on a tighter budget, then the Ender 3 is going to be at the lower end of the budget. But there's some really good printers out there that are not that expensive. So the one that I have here, let's see, let's go back to it. This one. Now this one is one that I used in class in the winter, and it does have some non-standard parts on it. So there are different pieces here that I've added, but the base printer, so the main pieces of it that you would need to print, I got it on a Black Friday sale for $99. I looked last week, and I did not see any sales for Ender 3s that were that low, but you can still get a basic Ender 3 in the 180 range. It's about the cheapest I saw, other than like refurbished and things like that. Sometimes, I didn't look here, but sometimes there's a website, Comgrow, COMGROW, and they have some refurbished printers that are relatively cheap if you're looking at the super low end. And they go up from there. 3D printers go up from that price point to as much money as you want to pay. There are FDM printers that are in $100,000, but they're very specialized and they're not something that you're going to have at your house for most people. But Ender 3, Bamboo Lab has some good ones. Creality has other good ones that are a little bit more expensive than the Ender 3, but they're good. If you search around, you can find plenty of options. I would stick to FDM printing unless you just really want to venture out into some of the resin. Some of the resin printers are also equally cheap, but they're way messier and they have a lot of side accessories that you probably need to have in order to operate them. We will talk about resin later on in the quarter. Here are some of the things. I don't know if I would necessarily say you had to have the hairspray anymore. The hairspray was one method that I would use to keep parts to stick to the bed, but now there are bed surfaces that are pretty good that you may not need the hairspray as much as you once did. Scraper, something to get the part off of the bed. Now this printer has a flexible bed, so you can just peel it up. It's magnetic, and the parts will generally pop off of it. One thing that you might want if you do own your own printer is a fire extinguisher. I've never had it happen that a printer caught fire, but it is a possibility. You are printing at 200 plus degrees Celsius, so there is a significant amount of heat involved. So there is a possibility that you could have some kind of fire. So fire extinguisher, the ABC dry powder kind, just better safe than sorry. They're not that expensive. Probably need one anyway around your house. But I do have one of those handy just in case. Never had to use it, but just in case. And then most printers now come with some sort of spool holder. Actually, the one that I've got sitting beside me doesn't have one on it. But there are different kinds of spool holders. We'll talk more about that later. All right, so let's talk about the, this mentions the winter quarter. We're actually in the summer. I need to change that. So we won't be meeting face-to-face. We will meet here. And if you don't meet during the lecture, that's fine. I'm going to keep the videos up indefinitely, so you can go back and watch them whenever you want to. Here are the kind of assignments that you're going to finish. I do have dates on these, but they're, like I said, it's the summer, and you might not be able to do something that particular week, or maybe your printer is not cooperating that particular week. So if you miss one of these deadlines, it won't be the end of the world. These are mainly to keep you on track so that you don't end up at the end of the quarter and have a whole bunch of stuff to do and your printer's not working and you got to figure something out. So these dates are the guidelines you should follow, but if something happens and you miss one by a day or two, that's not a big deal. I'm checking the chat over there in case anybody posts anything. So far I don't see anything. Did get a couple more votes, or a single more vote. Still looks like there are none of you that have not printed or not had something printed. So let's look at these breakdown here. So the repeatable one, that's the benchy. So this little boat is what you will print, and this is the single print that I will grade for like details. There's a whole rubric for grading it. It's a generally good benchmark print for, is your printer doing all the things it's supposed to be doing. The other prints, I'm just basically going to grade that you did them and you put some effort into it, but I'm not going to get very picky about, oh, you got a droop there or a line out of place there or a blob there. I'm not going to worry too much about that on the other prints. But this one I am. This one I am going to worry about, and I'll give you feedback on things that might be causing any defects in your print. That one you can turn something in every day if you wanted to. All of this gets turned in Canvas. There's no physical turn-ins because who knows where everybody's at. So it gets turned in Canvas, and you have to turn it in with pictures. So you will have to send a set of pictures to me to grade that one. The others, a single or two pictures is fine, but this one, it takes about a picture from every angle, to make sure that I've seen all of the pieces of it. So it does take more pictures. But if you turn it in and I grade it and you think you could do better, you can turn it in again and reprint it, turn it in, make some tweaks in your printer or your slicer, and try again. The others aren't like that. That's just the only one that's repeatable. There are a set of calibration prints, and most of these will go throughout the quarter. So if you don't know what they are yet, that's fine. Calibration prints that help you make sure your printer is printing as well as it possibly can. There's a contest. We'll have an in-class contest that you can join for this option. Well, not option, but this requirement. Or if there's a contest out in the wild somewhere that, hey, that one looks interesting, I want to join that one, just show that you entered this other contest that you found on printables or whatever it is. You don't have to win or anything, just you entered it. And here's your submission, and we can look at it. And then there's these 5 options. We'll talk about those in a second. There are 2 quizzes. They're just in Canvas. They're multiple choice, maybe some fill in the blank type of things. There is a technical brief. So at the end, you write a paper of sorts. So there's some options on the types of paper that you can write. And we'll look at those in a minute. That's at the end of the quarter. And then normally there'd be an attendance grade, but since we're all online, then that doesn't make as much sense. So it's more participation. So did you participate in the YouTube streams? Maybe you just chatted there. Did you participate on the Discord channel? You post some questions, answered some questions. Did you, when somebody turned in an option here on Canvas, did you go make comments on it? So you just participated somehow. Periodically throughout the quarter, once a week or so, you made a effort to participate in the ongoing class. These are all the descriptions for the various things. Here are the options 1 through 5. So there's a whole list. Every one of these is a different thing. So there's a bunch of them. We'll just, there's the last one. And maybe you decided that, the PLA was interesting, but I want to try this other material, PETG. And so you do this assignment and you print something, doesn't matter what it is, but you use a PETG material, which is different from the kind of standard material everybody uses called PLA. And you submit that as your assignment here. So you choose 5 of these things. And maybe there's not one here that really fits what you want to do. Just tell me what you want to do and we'll make a category for it. Here's some of the options if you don't have a printer available. Maybe you don't have one and you don't have access to one. Then here are things that you can do that don't require you to actually print anything. So, and if there's something there that you would want to do, if you had a printer, but we need a non-printed option, then we can make those up. This is kind of my grading rubric for all of those optional assignments. Mostly, did you do it? And then 30% that, well, did you put effort into it? You know, did you try versus you just threw something together and turned in a kind of sloppy print. So most of the time, you're going to get all 100 points on those optional assignments. Here's a little bit about the technical brief. Here's a couple of different options for what you might do for the technical brief. There's a couple others. There's the contest. These are some typical contests that are out there. I haven't looked yet for any that are like on the internet anywhere. We'll have a class contest also that you can just use that one if you don't want to do any of these other ones. We mentioned, this says Moodle. This will be Canvas. I'll change that to Canvas. And then we talked about the participation, and that's your regular. So I don't think anyone's taking for graduate credit, but if you are, then there is an additional assignment. Or I didn't see any honors credit students, but if you're doing it for honors credit, then there's one of these extra assignments to make it honors or graduate credit. I didn't see anybody doing that, but if you are, then I need to know so that I can set up the extra assignment for you. So that's the syllabus, and I'm not seeing. Oh wait, where is this on Canvas? This is in. Let's see. It's called syllabus. Let me see where it's actually at. So it's loading very slowly. So not in storage. It's right here in general. It's in the general one. Just called syllabus. And it's all of that stuff is in there. This turn in assignments here. This is where you actually go to upload all of those different things. So there's your option 1, whatever you decided to do there. There's the contest, calibrations. There's the perfect print. These are some files that for the benchy and for some of the temperature tower stuff, calibration stuff. There's a technical brief. So you turn in everything here in the one called turn in assignments here. I haven't put the dates on those yet. The dates are in the syllabus. And again, if you miss a date by a little bit, it's not a big deal. Then you'll be all right. All right. So what we're going to do today is go through all of that and answer any questions that you have. I haven't seen any others. Oh, we have 11 votes now. Still no no's. So we're still good on everybody's at least seen a 3D print. And most people have printed something on their own, which I assume means you have your own printer. If you want to, go ahead and put in the chat what printers you're using. I'm using the I'll be using a assortment of printers. So the one that I have sitting beside me is an Ender 3. So that's what I've got. But I'll use an assortment just so you can see what some of the different printers do and why you might want one over another one. They each have slightly different ways of approaching things. And there's advantages and disadvantages for different kinds of printers. Most of what I do, or what we'll do in class, will be the FDM, so the plastic modeling. Let me show you some examples of what I've got over here that we might print. Most of what I'm planning to do as examples throughout the quarter have to do with printing, like modeling something and printing something. So we'll do a little bit of modeling. Some of it might be in SolidWorks, but I think a lot of what the modeling I'll do will be in Fusion. So that's an Autodesk product. I might use some different software also. I'll try to have software that you can at least get a free version of, so that you can do the same thing. So most of you have SolidWorks that you can use, but eventually, once you graduate, you won't have SolidWorks unless you work at a company where they give you SolidWorks, and then it's for your commercial purposes, not really for your own private use. So I'll try to give enough options that are open source or free or really, really cheap throughout the quarter. So most of what I'll do will have to do with maybe making a part that we need, for a project or something like that. And we'll use some kind of CAD, Fusion, Plasticity, SolidWorks, Mesh Mixer, a lot of different things like that to create the geometry. Let's look at what I've got here. So in this, usually what I have here in the class 1, 2, 3 through whatever we end up doing, should be around 30. That's going to be where I put the link to the stream. So there's the link to the stream. It'll also be in the Discord, maybe a short description of what we're doing. Here's 3 of the links that we'll talk about today. And then there usually are going to be some older videos because I have streamed this for several summers in a row. In fact, I don't even have the last 2 summers in here. So obviously, as they go back further in time, things will be a little bit different. 3D printing, additive fabrication changes pretty quick. So I'm looking at this one from 2021. What I used to do, like this one right here, that's the box the printer came in, and you had to build it. So there's usually still a little bit of building you have to do, but it's kind of trivial now for most people. So if you have some issue with your printer, then you can ask in the chat or in the Discord, or we can set up a office hour Zoom type thing where I can see your printer and try to help you with it. But it's not as important now to building the printer as it used to be. Most of the printers you get now, you take them out of the box, maybe put a few pieces together, and they're pretty much ready to go. So we'll focus more on what can you do with them once they're running, versus what the class used to be was, well, how do you get the thing to work at all? The very first class was, I don't know, 10 years ago or something, and we had to build the printers from like individual pieces, nuts and bolts and extruded aluminum and that sort of thing. There was no pre-assembled anything. So I don't know if I have any videos from that far back, but some of these other videos, if you want, maybe you bought an Ender 3, if you're having some issue assembling it, some of these older videos are actually assembly videos for the beginning. We don't really need to do that now. If you do have some issues, then you can ask in Discord or set up a Zoom with me and we can figure them out. The voxel, oh yeah, the voxel lab. Those are, I've not used one myself, but for what they look like they're pretty good printers. Let's see, it keeps going to there. I'll usually have some little tip. You'll hear this term, did you level the bed? That is not meaning did you get a spirit level out and check that it's level with the earth. So what they mean is more like tramming, if you've ever used that term before on a CNC machine. But level the bed just means that the nozzle where the filament comes out once it's melted is parallel to the bed when it's moving around. That's what it means. And not all beds are fixed in place. This printer that's sitting beside me, it actually has a sensor on it right here. It did not come on there, but we added it during the winter. That goes and measures where the bed is at so that it can level it itself. It doesn't move the bed around, it just adjusts for any out of squareness that might be in there. We'll talk about those. You won't be able to see these are hidden to you, but if we were in person, we'd take an attendance quiz. So usually there'll be something that has some links to what we did that day, maybe some description, and then maybe a little tip or something else, or some supplementary video or something like that. So if you get too far ahead, these topics may or may not be what we actually talk about. That's what I talked about in the winter. We might do similar things in the summer, but we may or may not talk about those exact things. All right, so introduction, we've done most of that. First print, we haven't done that. Before we do our first print, I do want to show you the fundamental piece of hardware that makes these FDM style printers work. So I've got it here. We're going to have to reposition. Let's see there, make sure we're, yeah, right there. So what this is this is a hot end is what we would call it. this is not universal as far as they all look exactly like this, but they all have these parts in them for the most part. They might be arranged in different shapes and different sizes, but pretty much this is the standard FDM hotend. And there are 4 main pieces. So one of them is the nozzle. So see if we can get some pointer. Little nozzle right there. For the most part, they start out and they're brass. That's the cheapest ones. You can get a brass nozzle for a couple of dollars. Usually, if you buy them off of Amazon, you get 10 for $8 or something like that. They do make different materials that are more expensive, and there might be reasons to get different materials, and we'll go through those. But this is what controls the filament as it comes out of the hotend. And so there's a tiny hole. Can't even see it. I'd have to zoom in. I don't even know if I can zoom in that close. I can zoom in closer. Let's see. See if we can find it in there. Oh, we might get even closer. Let's see. All right, so we're zoomed in pretty good here. There's a pencil. You can see the nozzle hole right there. Let me read this one because I don't know. Well, it doesn't say. So, let's see if I can find it. That probably means that hole is 0.4 millimeters in diameter. That's the kind of standard size, but you can get larger, like up to a millimeter or more. You can get smaller, down to 0.1 or 0.2 millimeters, but kind of the standard idea is that there's a 0.4 millimeter hole in the end of this brass nozzle, and that's where your filament, once it's melted, it's extruded out of that hole and laid down in some pattern. So that's the nozzle. That's one piece. I'm going to zoom out now. We don't need to be so close for the rest of these. The nozzle is screwed into... I've got to get some pieces out here. This one's tighter. All right, there it went. This little block, so the nozzle screwed into there. This is the heat block. Let's see if we can get these kind of arranged where they go. Something like that. Nozzle, heat block. This hole right here is where your heater is going to go. And I did have a heater. Here's one. So most of them are little cartridge heaters. They're just resistors. So you put some electrical power through them and they heat up. So that usually goes in that little hole there. In a smaller hole next to that, you need to measure. So you do have to control the amount of heat that you're applying to these different filaments. So the plastic you're melting, they melt at different temperatures, and so you kind of have to control that temperature. And so there is a thermistor, which I have one here. Got to get it out of the bag. Oh, let's see. So here's a thermistor. This is a little glass bulb thermistor. It's used, let's see, this one is, it's going to be in this little hole right here. So it's measuring the temperature of this block. And, you know, the heater cartridge over there is heating up the block. And your printer is monitoring the temperature through the thermistor, which flew off the page there. There it is. Doesn't want to stay where I put it. So thermistor's measuring the temperature. Your brain in your printer is regulating so that this block stays a certain temperature, 200-ish degrees Celsius up to, we probably, for our printers, won't go above like 240 Celsius. But there are materials that do have to go hotter than that to print with, but this particular printer setup will not really do that higher temperature too easily. So I've got a lot of heat right here going into this nozzle. This little piece is called the heat break. So the short section of it screws into the heat block. The longer section of it screws into the heat sink. So this part's the heat sink. So going to be really hot right here. Your filament, actually there's a little piece of that little white piece. It's a piece of filament I left in there from who knows when. Your filament's going to go down through here, be melted in this zone here, and then formed into a, in this case, 0.4 millimeter stream, and deposit onto your print bed or your print that you're printing. This part has a fan blowing on it that keeps it cooler so that your filament's not melted way up here. So this heat break has a tiny little section in here that mechanically connects these two, so they're fixed together, but tries to isolate the heat. So keep the heat down here, don't let the heat go up here. If heat goes up here into this area, then you're going to have molten filament in here, and you're going to get clogs, and it's not going to print at all, or at least not very well. Another piece that's stored on most of these printers is this little connector type here. So there's generally a tube that is feeding filament into here, or guiding filament. It doesn't feed it, but guiding filament into here. And most of them use this sort of setup here, where you push this down to remove the tubing. Here's some tubing. So the tubing might look like this. It may not be blue, but so the tubing would go in here. And sometimes the tubing goes all the way down into here. You know, this one, the tubing's going to end up down in there. Some of them, the tubing ends in different places. We'll talk about why that is later on. Some of the printers don't have a very long tube. They just have a really short one. And others have, like this is, you know, really long. Can't even see all of it. But we'll talk about those types of printers and why you might want one or the other later on. But I think understanding these pieces here, will help you troubleshoot when things start going wrong. Understanding what each of these pieces, what the purpose of it. So form the filament, heat the filament, connect the heat to the cold side, the hot to the cold side, and isolate the hot from the cold side. Cool off the metal here so the filament's not melted in here. So you've got nozzle, heat block, heat break, heat sink. Those are your main pieces that almost all of these printers are going to have. They might have different materials. So in general, you've got brass, you've got aluminum, you've got steel, and then you've got aluminum again. But you might have hardened steel. These are mostly aluminum. But there might be some other materials, mostly aluminum here. These could be two different materials. They could be steel, they could be titanium, they could be different materials. And again, the heat sink is usually aluminum, because the parts that are dealing with the heat the most, either trying to keep it cool or to heat it up, have the materials with the better heat conduction properties. So aluminum is generally better for that. But you'll see different materials for some of these. Some of the materials that you want to print are really abrasive. So they might have carbon fiber in them, or they might have some kind of grit in them. And this little brass nozzle is just going to get eaten away trying to print those. So you might have to switch your nozzle to a harder, like a hardened steel, so that it doesn't get chewed up just by printing. Or maybe you want to print regular materials and you'd rather have brass because its heat conduction property is better than a steel would be. So there's reasons that these are different materials sometimes, but in general, that's what all of these printers are relying on. Let's look at let me put this back together before I lose any of the pieces here. Actually, I should probably put this, that one's really easy to screw in. Let's put this in here first. We will actually talk about how to assemble these, because you can't just screw them together and hope for the best. There is actually an order that you should do so that you don't get, if you ever take your hot end apart, there's an order for putting it back together in a procedure so that you don't have leaks, because the filament inside here is under pressure. It's being forced out, and it's molten. So if you don't assemble this correctly, then you'll get filament coming out here or even out here. you'll get jams inside here, clogs. So I did not do any of that. I just stuck these back together so that I don't lose the pieces. Let's look at two other tools. This one usually comes with your printer. So you almost always need this pair of snips for cutting the filament generally. So whenever you're feeding in some filament into the printer, it's nice to have it at an angle so that you can, I'll show you. Let me get a little short piece of filament here. So you cut it at a sharp angle so that it's got a point on it so that you can feed it into your filament, into your printer easier. And these things are good for that. And they usually come with the printer. Usually that's just a thing that happens. I also have, this is for painting really. So this is a palette knife. Now it's got a little bend in it up here, but it's a spring steel, so it's pretty flexible, pretty flexible material. And it's super thin. So really thin. And I usually use something like this for getting parts off of the print surface. So, like I said earlier, this printer has a spring steel, but sometimes there are really thin like purge lines across the front or something like that that don't just peel off of there. Something like this usually does not come, well, here it is, usually does not come with the printer. They do give you a scraper, but it's usually not a thin piece like this. And this will usually get up under most things and peel them off of there. So I do have one of these. I'll put a link, if I can find it on Amazon or somewhere, I'll put a link to something like this. But this is a painting tool, actually. So, for like oil painting. All right, so let's look at some of the things that I have printed so you can kind of get an idea of what you might print. So, well, here's kind of a standard part. This is a little wireless module for a robot, and it needed a header. And so years ago, like, I don't know, 12 years ago, maybe longer than that, modeled up this. This is just PLA. Actually, this material, I don't remember. I think it's just PLA, but I don't actually remember what material this is because it was so long ago that we printed these. But this is just a thing we modeled and printed, and it holds some different parts that we can easily plug in to a robot. Oh yes, on the benchy. So there was a question when you're printing your benchy. We haven't really talked about slicer settings or anything, but one of them is called supports. Yes, do not print the benchy with supports. So no supports on the benchy when you print that one. All right, so functional parts are things you can print. This one's over a decade old, I know, and it's still going strong. Ornamental parts. So here on the web page, one of the links I had was to Toy Maker. I'll show you here. Toy Maker 3D, actually, without an E in there. There's a link to that. You can kind of can you see it? No, I don't think you can see it. Let me move it down where you might. Well, maybe you can't see the thing, but you can see it there. That's the web address. .com. These are multi-part little prints just for fun, but there are some of the assignments that are multi-part prints and a variety of things that if you want to print one of these guys, this is Optimus Prime. Here is one I printed so you can see one in person. I guess I need to show it to you. There's one. He's upside down, isn't he? Let's go this way. There he is. So these are different colors of filament, not painted. It's just different colors of filament, and he all snaps together. I think I glued some of him together, but he's articulated, so has moving joints and such. So you can print just for fun things. Maybe you want some high detail things. This guy is painted. This is FDM printed. So on a printer just like this one with the same nozzle, you know, 0.4 millimeter brass nozzle. You can get, now this one he is painted though. He's not, you know, he was one color beforehand, and then I did paint him. But this is a FDM print. Now, it might take a while. This might be a 4 or 5 hour print possibly, because you got to print very small layers. In fact, let me see if I can, yeah, you can see the layers here. So if we get close and we zoom in, I think you can see some layers. Yeah, you can start to see them there. So kind of across there, you can kind of see some layers in there a little bit. Maybe you can see some over in that area. So they are visible, but you've got to zoom in. You know, this guy's only 1.5 inches tall, maybe. Here's more. Here's more what he really looks like. So you can get some really fine detail out of a regular FDM printer. But just for comparison, here's another guy. This one's resin. So resin, FDM, both painted. Neither came out of the printer in these colors. So they are painted. So we'll talk about these resin prints. The only reason I don't spend a whole lot of time on them is that it's a messy process. FDM is not very messy. It can smell, so you do have to be aware of the material you're printing and where your printer is. So my printers are back in a separate little So that one is showing with a bamboo A1 in there, so it's a little bit smaller. This one has some ducting that can actually vent it outside if you want to. But they're all generally the same except for the ones that are hard shells. Like this one, it's got a filament rack and it's a hard shell. It's got feed. This is a whole other level of thing. But these work fine. Plus, the other benefit to these is that they do contain any heat. So generally heat is good around the printer, around the print that's being printed to keep it from warping. In general, that's a good thing. So that's an option if you don't have a place where you can put the printer out in the garage or out in this other room or something, then these can help with that. All right, back to where we were. We were looking at things that were printed. So we were looking at those two guys. let's see. Oh, I have a larger just to go with those. FDM, so you can print larger things. Now this one's in 2 pieces, but you can actually see kind of right there is where they're joined together. Again, you can paint this stuff. We'll talk about some of the things you can do to paint them and have the paint work a little better than just painting straight on the raw plastic. Although this guy's not painted at all, he looks pretty good. He definitely doesn't have the number of details that the others do. But these are all things that you can print. We'll take him out for now because he's resin. These are all things you can print with just a FDM printer with no special things, just PLA, your brass nozzle that it came with, and no particularly special settings. Any settings would be in the slicer that are available to whoever, nothing fancy. All right, let me just show you the, let's see, I think I've shown you all of that stuff. So let me show you a little bit of slicing, what that means. I brought up Cura, so I'll use a variety of slicers just so you can see some of the different ones. Cura is probably the most commonly used one. I'm not sure if it is anymore. For a long time it was. It was the one that most people used, and there's nothing wrong with it. But people have started migrating to different slicers. But Cura is probably the one that you'll start with. Maybe not, but probably. It kind of depends on what printer you start with. It's open, it's free, so you can use it without having to pay for anything. It is managed through Ultimaker, so they are a company that makes certain printers. But you don't have to only use their printers. Cura will work with pretty much any printer, and most printers that you're going to buy have a profile already ready to go, so you don't have to go build it yourself. Even though they want you to use Ultimaker, most every printer has a Cura profile built in that you don't have to worry about. So that's probably what we'll start with today. I had showed you this guy, another one. Another big competitor currently is Bamboo Lab, and they have a site called MakerWorld, makerworld.com, which is what we're looking at here. And maybe not all, I think most all of these are free files that you can download. Look, some of these are laser cut. Most all of these are free files you can download. And all right, I think we're back. So, little network hiccup there, but it looks like we're back now. All right. So I was just talking about most of these slicers are built off of 1 or 2 open source slicers, and they put their own spin. Each company puts their own spin on it. But this one is specific to the Bamboo Lab series of printers. I have one of the X1Cs that we'll use also. This is their way that you can get files. You can upload files, you can download files, and they've got just a whole variety of things. Some of these are set up for laser cuts too. Why I showed you this one is that they have a pretty interesting thing called Maker Lab right here, kind of at the top. And what this is there are a lot of AI enhanced geometry creation files. So they've got all of these and some experimental ones that I haven't used yet that you can use to create your own geometry based on a text prompt or an image that you've drawn, or you've used AI to create the image. And there's some pretty cool things that you can do here. So I think the internet keeps pausing and restarting on me. So we're about done with the stream anyway. Oh, here it is right here. I'll try to keep an eye on it, keeping up. So this is a relief sculpture maker. Relief sculpture maker is the name of it. And you can take an image and create a relief. So, you know, this was just a picture, a literal photograph from a cell phone. And the process here, Maker World, Relief Sculpture Maker, created the geometry. So, you know, there's actual physical geometry there. And then you can export it and print it out as an actual object. So there are a lot of different things here. This is just one of them. I'm trying to get back to their main, maybe if you click on Maker Lab. So they've got a flexi toy maker, a light box maker. We were looking at the relief sculpture. You can make kind of a fantasy creature from a text prompt, a statue from an image, lithophanes, color or otherwise, just a parametric like a pattern. You can make a little keychain based on the image, a desk organizer to hold pens and pencils and whatnot, little pixel puzzles, so kind of like perler bead type of things, a vase maker, a sign maker, and then they've got some experimental ones down here. So they're all of these you can do mostly for free. You do have to have a little account. The account is free, and then you can earn points based on like filling out your profile and stuff like that to use your points to generate some of these things. Some of them are free, some of them take some of these points to do. Generally, you don't have to pay any money unless you do a whole bunch of them, though. All right, so that's one of the links there. We already looked at that one, and we looked at Cura. Let's look in Cura itself now. So let's go here. So this is Cura, and what we're looking at is, I don't even know, this is a Ender 3, so this little box here is not going to have anything in it if you've just installed Cura, and you would have to add a printer, and you would go through the, well, I'll click on it. You'd add a printer. Is it an Ultimaker printer? Probably not. They're kind of expensive, but maybe it is. Probably you're over here in the non-Ultimaker printer box. You probably don't have it set up as a network, so you add a non-networked printer. And then you start going through, well, what kind is it? And they've got all the brands you can think of. I would, if I were setting up this printer, I would have a Creality, if I can find the C's, Creality, and then it's a Ender 3. And going through that process will set up the printer profile so that the slicer, Cura, knows how big the printer is, what kind of stepper motors, it wouldn't know what kind of stepper motors, but it would know what configuration. Is it a Cartesian printer, a Delta printer, is it something else? So most every printer that you're going to buy off of Amazon or Walmart or Best Buy or wherever is going to be in this list somewhere. And then you just add it and you've got your printer ready to go. Now this one is set up as a what's called Clipper, so that means it's running a kind of a remote software. I've got it set up with a 0.6 millimeter nozzle, so a little bit larger diameter nozzle. I generally do print with 0.6 millimeter on these style printers just to print faster. So if I can have a larger nozzle, I can extrude more filament and it can just go faster. So I usually do 0.6. But if you're trying to print like, this little guy, you probably wouldn't want him at 0.6 millimeters. You probably want 0.4 or even smaller nozzle. We'll do a nozzle change so you can see the whole process for that later. Not today. We're about out of time today. And then we need to put a model in here. So let's go to find a model. 3D models. Let's just find something that we can check in to make sure we're back. I think we are soon. All right, I think we're back. I can download a STL file, and let's just get this one right here. I'm just going to download it. I don't want all of them. I'm just going to download that one. All right, so now I've got the file. Maybe you saw it pop up over here in the download section. So now I can open a file. That went into my, this is it right here. STL is kind of a generic 3D CAD file. I wouldn't call it CAD file, just 3D geometry file. So STL files have been converted to just triangles. So we'll look at all that, what the mesh and all that kind of stuff later. But you're generally going to look for an STL file. There are other kinds. 3MF was one of them. But STL, we're going to download that guy and open it in Cura. He gives me a preview of what it is I'm going to print. Looks like this has threads in there that it's going to thread into a bottle of some sort, so I can funnel straight into there. This little area here is showing where it's contacting the bed. I'm thinking that's okay. That's probably enough. If this was really thin, then I might be worried that it's not going to have a lot of area to stick to the bed, and it might pop free. You know, it might come off of the bed. But I think that's enough area. If I'm worried about it, I can deal with that. And then over here, I've got kind of a couple of ways I can approach this. Here it says standard quality 0.2 millimeters. What that means is that, oh wait, that's under my, no, it's right there. You can see it. Standard quality 0.2 millimeters. That's the layers. How thick are the individual layers? So remember, I'm printing. Well, actually, I'm printing on this one with a 0.6 millimeter nozzle. You're probably printing with a 0.4 millimeter nozzle. The general rule of thumb, not like hard and fast, but general, is that you can print layers that are as thin as 25% of the diameter of the nozzle and as thick as 75%. So with a 0.6 millimeter nozzle, I could go down to 0.2 millimeter layers and feel pretty good that it's not going to be too thin for the nozzle to deal with. Now you can go outside of that 25 to 75% range, but this is just kind of the standard. So that's what that's telling me. This little symbol is telling me, well, if it is not solid, so like there's in 3D printing for FDM printing, you print the shell of the shape, and then the interior part may not be solid. It might be kind of just to save plastic and to save time, get the print done faster. It can be honeycomb or kind of sparsely filled on the inside. This is saying that it's going to be 20% filled. So it's not going to be solid. This little symbol is saying that supports are on. So we talked about the supports. I don't know that this one needs supports. So I might, well, when I click on this, I get a lot more. I didn't want to bring these up just yet because it starts to get more and more options here. But actually it says I'm on 0.3 millimeter layer height here. I don't know why that one says 0.2. I guess I just never renamed it. So 0.3 millimeter layer height. Again, I've got the 0.6 millimeter nozzle. It can do 0.3 pretty easily. And it would be faster if I can do thicker layers. There will be fewer layers to print. Walls is how many of these shells do I want to print before I start printing the interior that's kind of sparse. So 2 walls is generally the minimum. You can probably hear the dogs. The dogs have decided that something is important. So 2 walls is the minimum. If I want it to be stronger, then I would do more walls, maybe 3 or 4, but I would do 2. 1 wall is a special case that you might do occasionally, but not too often. Top and bottom. So how many solid top layers and bottom layers do you want to have? 2 and 2 are usually okay. Sometimes you want more, but 2 and 2 is generally good. Here's that infill, 20% solid. There's the temperature. If you choose the material to be PLA, 205 degrees Celsius is generally good. Build plate temperature. Build plate is this surface right here, whoops, is the build plate, and if it's heated, that will generally help the parts to stick to it better. So over here you can see the build plate temperature set to 50 degrees. That's kind of a standard temperature for PLA. Speed, you can go faster or slower. Generally, slower will make the part come out better. It'll just take longer. Faster, obviously it's faster print, but your part might start to suffer. Now, I don't think this part would suffer generally because it's just a bunch of circles. Cooling. So remember, when we talked about this piece, we talked about this part needing to be cooled. That's not the cooling in the slicer. This part should have a fan that's independent that just always blows on it. But there should be another fan that's blowing down here on the freshly printed part. And different materials like different amounts of cooling. So I'm thinking I'm going to print this in PLA, and so I would print 100% cooling on the part cooling, or they called it print cooling here. Support, I don't think it needs support, so I'm going to uncheck that. We'll talk about support later. Build plate adhesion type. If I thought that there's just not enough material, this cyan color, there's just not enough of it, and it's going to come loose from the bed during the print and it'll fail, then I could have some options here for adding other area for it to stick down better. I'm going to leave it at skirt and call it a day. So you get all these settings set the way you want. We'll talk more about the individual settings later. This is just the intro. And then you hit some button that looks like slice. So it will take all of the settings that you've picked out and it will apply them to create this shape in individual layers. So it's telling me that it can print this in 1 hour and 5 minutes. I'm going to do preview to see what it's going to print. This is what it's going to print. You can actually, if we zoom in, you can see the individual layers there. Each of these layers is I think we said 0.3 millimeters. This little track around it is the skirt. I usually print that just so I can kind of see, it'll print that first so I can kind of see that everything's working and it's going to stick down. This little slider works through the individual layers. Let's see if I can find some. Well, this one's so thin that infill, oh, there's some. So see how there's squiggly lines in there? That's the 20% solid, although it's not like 20% by volume necessarily, but 20% infill. Most of these were just solid because it's so thin. So this is what I would get. You can kind of even see the threads in there. If I wanted those threads to resolve better, I'd have to do thinner layers. So let's just do that. Let's say that 1 hour is not that long. Let's say that I want more detail in here, so I change it to 0.2 millimeters. It cancels the preview because I've changed the slicing settings, so I have to slice it again. It was 199, well, technically 200 layers, because I think it started counting at 0. Now I've made the layers thinner, and so there'll be more layers, and it'll take longer. So 1 hour and a half, so not that much longer. I've got 297 layers. Oh, it did start at 1. Okay, so 297 layers. So I've got another 100-ish layers, and they generally look the same, but I've got a little bit more detail on those threads in there where I thought I might need a little bit more detail. And it didn't take me that much longer, but you know, if I start making this 0.1, I don't even know if I could get a 0.6 millimeter nozzle to print that thin very well. Maybe it would. It's going to take longer and longer to slice and longer to print, but I'll get higher detail out of it in the end. In general, if you're just printing a regular part, 0.2 millimeter layer thickness, 20% infill, 2 walls, 2 or 3 top and bottom layers, and it'll work. It'll be fine. So once you need very specific things like stronger or faster or higher detail, then you start modifying those settings. Now I've got nearly 600 layers, and it's going to take nearly 3 hours to print, but you can kind of see the threads are way more detailed in there. It's just starting to take longer and longer, probably longer than a funnel needs to take to print. So that's the general idea. I would save this to a disk or send it to my printer. Usually save to disk means save on a SD card. I don't see one handy right now to show you, but you know what an SD card looks like. Most of these use the little micro SD cards for the printers. Some of them, some printers, you can hook up to your Wi-Fi and just send the file straight to them and not have to worry about it. All right, I'm going to check the chat. All right, I don't see anything new in there. This will be enough for today. Should get you an intro to what we're going to do. Give you a little basic idea. Most of you had printed stuff though, so I think you've done a slicer, so you don't need a lot of details there. We'll come back on Friday at 8 o'clock. And again, I'll keep the videos up indefinitely, so you'll always be able to go back to them. But if you have any questions, put them in the Discord. I'll close this chat down pretty soon, so it won't be active for much longer. And we'll be back, and we will do some more interesting printing, some actual modeling. I think I'll use Fusion on Friday, and we'll start doing some real printing. So I'll see y'all on Friday.